In this video, we will look at lines. So in terms of dealing with lines, the first thing that we need to discuss is the slope. The slope of a line through 2 points is given by the following formula, where we can really think of this as representing rise over run. So the rise, if we draw kind of a triangle associated with those 2 points, is how the y values change, and the run is how the x values change. So let's find the slope of the line through points -2, 6, and 5, 5. So the slope is going to be the difference of their y values, so 6 minus 5, over the difference of their x values, -2 minus 5. So 1 over -7. One thing to be careful of is to make sure when you're using this formula that in the top here we've done 6 minus 5, so y2 minus y1. We have to make sure that we use the points corresponding to the same x coordinates in the bottom. That is, we have to divide by -2 minus 5. So be very careful of that. Let's now mention the 2 basic equations of a line. The first is the point-slope form. If we want the equation of the line through a specified point x1, y1 with a slope m, it's given by the following expression here. Y minus y1 equals m times x minus x1. And this point-slope form of a line becomes very important when we get into the calculus topics later on. Now, to see where this comes from, if we have the point xy on that line, and we know the slope is m, well, that means that m is equal to the rise over the run. And if we rewrite this in an equivalent way by multiplying by the x minus x1, what we end up with is an equation equivalent to that point-slope form of a line. In a similar fashion, the slope-intercept of a line, if you have the y-intercept and the slope, the equation is simply mx plus b. So let's look at a few examples. Let's find the equation of the line through the point 2, 2 with slope 3. So in this case, we are going to use the slope-intercept form, or excuse me, we're going to use a point-slope form of a line because we have a point and a slope. And to make the comparison, we're thinking of the point here as being the x1 comma y1, and the 3 as being our m. So the equation of our line is going to be y minus y1 equals the slope times x minus x1. And this would be the equation of the line in point-slope form. Now, a different type of question we can ask is, for the line given here, can we find the slope and y-intercept? Well, in order to do so, we're just going to put it in that slope-intercept form. So if you ever have a line written in the form y equals mx plus b, the slope is m, and the y-intercept is the point 0, comma b. So let's do a little bit of algebraic simplification. Divide each term by -4. This becomes y equals minus 5/4 x minus 6 over -4 becomes plus 3/2. So looking at the form of this equation, we see that minus 5/4 is going to be our slope, and the y-intercept is the point 0, comma 3/2. Now, one last example dealing with lines. So for the line given by equation 3x plus cy equals 5, can we find the value of c, which makes some various different things true here? So the first thing we want to know is, for what value of c does the line pass through the point 3, 1? That is, when we plug in 3 for the x value and 1 for the y value, we want that equation of the line to be satisfied. So 3 times the 3, the x-coordinate of our point, plus c times 1, where y is the y-coordinate of the point, we need this to be equal to 5. So 9 plus c equals 5. So in this case, c is equal to minus 4. For part B, we would like to know what value of c will make this given line parallel to the line 2x plus y equals minus 1. Now recall that two lines are parallel if and only if they have the same slope. So let's put both of these lines in that slope-intercept form. So this can be written as y equals minus 2x minus 1. So in this case, the slope of, and I'll put m sub b, the slope of the line in part B, is equal to minus 2. What we need to happen then is to pick the c value so that the slope of the line given here will be minus 2. So cy equals minus 3x plus 5, and divide by c. Y equals minus 3 over cx plus 5 over c. And we need to choose the value of c such that the slope of our line is equal to minus 2. So we need the slope to be equal to minus 2, and we know our slope is minus 3 over c. So divide both sides by 2 and multiply both sides by c. So c needs to be 3/2. For the part C, we want to pick the value of c for which our line is perpendicular to the given line. And recall that two lines are perpendicular when their slopes are negative reciprocals of each other. So let's go ahead and find the slope of the line which is given here. This, if we add 2 to both sides, y is 3x plus 11. So the slope, and I'll say m sub c, this line in part C, is 3. So what we need to happen then is we need the slope of our line to be the negative reciprocal of 3. So we need it to be minus 1 over 3. And from our work in part B, we know our slope is minus 3 over c. So minus 1/3 needs to be minus 3 over c. So what we can do here is multiply both sides by c and divide and multiply both sides by minus 3. So multiply by c, multiply by minus 3, c ends up being 9. So two very important characteristics here. Two lines are parallel if and only if their slopes are equal. Two lines are perpendicular if and only if their slopes are negative reciprocals of each other.